Okay, so we're picking up where we left off with relations. Remember, a relation is a group of ordered pairs, but we're focusing on being able to show them in a table and then a graph. So we're always going to start by annotating because these are word problems. So we have Jaden, he's designing buttons. The total cost can be found with this equation. C equals 0.5b plus 8. C is the cost, and B is the number of buttons. So we need to create a table for the cost of 10, 20, 30, and 40 buttons. All right, first of all, let's fill in the table. Remember, this is X, this is Y. The expression goes in the middle. So just everything after the equal sign. So 0.5b plus 8. Now, they're not using X and Y. Remember, they usually like to rename those for whatever's in the problem. So what am I in control of? Am I in control of how much it costs or how many buttons I order? I'm in control of buttons. So this is going to be the number of buttons. And they're calling it B. Just so you know, it's not X in the equation, it's B in the equation. And then Y is going to be the total cost. And they're not calling it Y, they're calling it C. All right? So now, what numbers do I fill in? Well, they told me 10, 20, 30, and 40 buttons. So I need to know how much is that going to cost. So I'm going to plug in, instead of B's, I'm going to put these numbers in its place. So half of 10 plus 8, half of 10 is 5, 5 plus 8 is 13. I put the dollar sign because it's money. You don't have to. And we're going to do that for each row. So we have half of now 20 plus 8. Half of 20 is 10. 10 plus 8 is $18. And then we have half of 30, which is 15 plus 8. I believe that's 23. And then we have half of 40 plus 8, which will be 20 plus 8 for $28. So here's the table that shows me how much Jaden will pay depending on how many buttons he orders. And these are ordered pairs. So if I wanted to graph it, this ordered pair would be the X comma Y, which is 10 comma 13, or 20 comma 18, 30 comma 23. And what this means is 10 buttons cost $13. 20 buttons cost $18, etc. Okay? So if I look at this table, it is telling me the exact price for 10, 20, 30, or 40 buttons. That is it. Okay? That's all I can see from the table. I don't know 50 buttons. I don't know 60 buttons. I don't know 100 buttons. I only know the number in the table. If I want to know the cost for any number of buttons, well, that's what I use the equation for, right? The equation allows me to figure out the cost for any amount of buttons because I can plug in for B any number I want. So the equation is good for any number. A table is only good for the specific numbers in the table. What this question is asking you. How are the tabular table and algebraic equation representations different? How is the table different from the equation? So the table gives the cost for 10, 20, 30, or 40 buttons only, comma, but the equation can give you the cost of any amount of buttons. That's why equations are great, because you can use them to figure out anything rather than just really specific examples.